Right, so today we're going to attempt the add two numbers medium question in LeetCode. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except the number 0 itself. So with this statement here, we know that the number 0 could be given to us. So in this example, we can see that we are adding 342 and 465. So we can see that 342 is in reverse order. This is in reverse order. So our singles are our head. So in our head, we had the single digits here, right? So 2 plus 5 equals 7. And then in the second row here, we have our, and in the second column, we have our 10. So 4 plus 6, we get 10, right? And we carry the 1 and we put it here. So 4 plus 4 is equal to 8, right? So with that being said, let's start implementing the function. So the first thing that we need to do is we need to malloc our head node that we want to return, right? So we malloc it as the size of struct list node, and our next job is to keep a current tracker. So we set our current as head. So this will be the one that we're using to iterate through everything, and head will just be the one that we return at the very end. And now we also need to take care of carryovers. So right now we initialize carryover as 0 because there is no carryover, but we must initialize it outside of the while loop. And we also must keep track of whether it is the first iteration or not. So we set the first iteration is equal to 1, or you could also do bool first iteration equal to true, but we'll just use 1 for now and just think of that as true. Now we have to have a while loop, right, to actually iterate through the linked lists. And one of our first conditions to check if that list 1 is not equal to null. And our second condition is also whether list 2 is not equal to null. And the reason why we have an or here is that maybe list 2 is currently null while list 1 isn't. So if we have like 42 plus 100, when we are adding the 100th values, list 2 would be null because 42 doesn't have a 100th value, right? But we still need to enter the loop because we still need to add on the extra 1 on the 100th place. So that's why it's an or and not an and. And our last case for our while loop is we need to check whether carryover is equal to 1. Because if carryover is equal to 1, that means we have value that is not yet added onto our linked list. So in the while loop, we first need to initialize a number, and we set it to carryover. And in the first iteration, it will be set as 0. In the subsequent iterations, it will either be set as 0 or 1, depending on what the value of carryover is. And we need to have an if condition, because we first need to check whether list 1 is not equal to null, because sometimes it will be and sometimes it won't be. So we're double checking whether list 1 is equal to null, and if it isn't null, then we know it's safe to access the list 1's value and add that on top of our number. And once we add it on top, then we can just move it next, right? So we can just move list 1 and set it as list 1 next. And we do the same thing for list 2. So we have the if statement, we check if list 2 is not equal to null, we add the list 2's value onto our number, and then we move list 2 along. Right, and then now we have to deal with the carryover. The way that C works is that when you are given a number such as 15, you take 15, you divide it by 10, and it returns 1.5. It will round it down, so it will get rid of the decimal points afterwards, so it will ignore the 0.5 and it will just return 1. So carryover will be set as 1. Same case if it was like 19. So 19 divided by 10, you get 1.9, but C ignores the 0.9 and it will just return 1. And in the cases where a number is less than 10, so let's say a number is 5. So 5 divided by 10, it will give you 0.5, right? So it will get rid of the 0.5 and it will return 0. So carryover will be set as 0 in that case. That way we can handle carryover as either 0 or 1. And if in the case that our number is exceeded 10, then we have to modulo it by 10, right? And in the cases where it isn't exceeding 10, then modulo it by 10 will just result in the same number being given. So 6 modulo 10 will just result in 6, but then 16 modulo 10 will result in 6, right? And then the 10 will just be here, located here in the carryover as 1. And then we have to check whether we are in our first iteration or not. So we have another if statement to check whether we are in our first iteration. What we want to do first is we want to set our current value as number. And in this case, since it's our first iteration, current will still be our head, right? Because we haven't actually touched current yet, so it will still be our head. So we're setting the head value as our number, right? And we're setting our head next. We're setting it equal to null, and we change our first iteration equal to 0. So now we're telling people that it is no longer our first iteration. So for every subsequent iteration, we need an else statement, right? So else, we need to first malloc a new node because we haven't created any other subsequent nodes yet. So we need to malloc a new node, and then we need to set the new node's value as the calculated number. And when we have a new node, we also need to set its next value as null. And now, since we are keeping track of current, we set current next to point at new node, and we move current along. So current is equal to current next. And after all that, we can return the head. So the head is keeping track of the head of our returned linked list, and we don't need to worry about current because current will now be at the very end of the linked list, so we need to return a head. And if we run that, it should work. Yeah, so as you can see here, all three cases works, and let's submit it. Let's see how well our solution is. Okay, that's pretty good, and that is embarrassing. But yeah, that is how you code the add two numbers function in LeetCode.